What's up mga ka-charts? Kaydale here and welcome back to the part 2 of the diffusion video. So I hope you enjoyed the previous video that I have made. No? And please, if you have any questions, don't hesitate to ask me in the comments below. Okay? So we'll continue with the part 2 of this video. Okay? So we'll be starting with number 29. Okay, so this is where we left off last time. So let's go to number 29. Okay, so to number 29. Okay, this is really getting difficult, no? Please forgive me if we take longer than usual. So let's try our best to understand these problems. Okay, so number 29 is type of equimolal counter diffusion problem. Yeah, and then let me draw the situation. So it's like having this okay. So if you here in the other side you have CA1 that the sana the concentration of the acetic acid in this area. So you have 0.125 mole per cubic centimeter, no? And then you have the length of your diffusion, length of the area, the path. So the path which is 100 cm. You have the diameter of this tube, no, which is 2 cm. The temperature is 25 degrees Celsius or 298 Kelvin, and then CA2, the same units, but it's lesser in concentration now. Okay, so what equation do we have to use here? You have to use the equation for equimolal counter diffusion. Okay, so you have Na, this is just J, NAT, but we are using the one, the stripped down version niya, not just the J. Okay, so you have CA1 minus CA2. Yeah. Okay, so we have the area, but we have the area because we have the we have the diameter man of the tube, and then we have the Z, diba? Z. So you can just you can really solve this problem. We have 4 dayon, it's 2 cm. Let's just use CGS units here. The diffusion, diffusivity, I got this from Paris. Okay, so it's 1.24 times 10 to the negative 5 cm per cube, cm squared per s. So find this in table 2-325 there. Please find this there. 100 cm, and then just 125 minus 0.051. Can get 2.88 times 10 to the negative 8 gmole per second. Yan. So let's see. Oh, dili siya near, no, but dili siya exact. It's not exact, but it's near. 30. Yeah. Number 30 is I think the hardest because it's very long. It's a very long problem that will be I'll leave the reading to you, but this is how I understood it. And also I got help from engineer Lara Lumbres. Ma'am Lara really helped me with this one, so I really thank her for this. Okay, and I think she discussed this in her videos, and I got this from her. Yeah. So the setup is okay. So it's like you have a tube, diba? Tube standing vertically daw kuno, and then you have air going out, and then you have um, what is that one here? What is uh, the liquid lang. So liquid, you have liquid at this level here, and then it is diffusing, no, evaporating there. You have it's filled daw kuno on 18 millimeters from the top, and then the whole tube no length is 40 millimeters. No, let's just list down the facts here. You have the diameter, which is 4 millimeters, the temperature, which is 17 degrees Celsius or 290 Kelvin, and then you have the time of 4 hours and 10 minutes, diba? Or let's just transform that to seconds na. You have 15,000 seconds, okay? Just transform that. And then you have your vapor pressure. Vapor pressure, you have 165 mmHg. We can use this later, because as you can see, the what is the transfer here, it is actually the unicomponent, no. This is what I have been hinting earlier, the last video, no. Because this liquid is just diffusing to the atmosphere. The atmosphere is not diffusing to the liquid, so that's why it is unicomponent. Yeah, diffusion. Okay, so you have the atmospheric pressure, which is 1 atm, which is equal to 760 mmHg, diba? So you have the density of 790 kilograms per cubic meter, and then you have the molecular weight of that liquid be where is it? That's 58. And we are to find dV. Okay, so we are to find dV. So how do we go for this? So first step is that we have to find the moles of liquid evaporated. Okay, so we have the kmole evap. Okay, kmole evap. Ay nako. Sige. So kmole evap. So how do we get this is that we have to find the volume first. Okay, volume. So it's that volume of the liquid that is evaporated, transform that to mass by using the density, and then by using the molecular weight, then you can get the kmole and evaporate. Okay, so you have 0.04 m, that's the volume, and then pila ang how much is the how much did it go down, diba? It's 9.5 millimeters, so 5 kana. So next yun is that you have to multiply that by the density, so that you can get the mass, and then divide that by the molecular weight, so that you can get the kmoles. Okay, so you have 1.626 times 10 to the negative 6 kmole, okay, of the liquid that is evaporated. Now let's go for our our equation that we will be using. No, so this time it will be very different. Okay, so it looks like this. C, which is your PR over P over RT, and then your dV, and then your Z, and this is what I have said in the last video, it's logarithmic. Okay, kung unicomponent diffusion. Okay, so we have right here the actually all of what we need, you know. This is what is this is what is required, you know. So let's supply all of this NaAT kana supply na to na siya tanan. So Na, this is actually your Na, no? This is actually your Na. Area is, yeah, we can finish siya gapon no 4, diba? Well, let's provide those, no? So Z is I'll tell you later. Time is we have 15,000 seconds, no? YA2, diba? Walay there is no at the beginning there is no concentration of YA, the liquid in the atmosphere, no? So this is 0. This is essentially YA2 is 0, but YA1 is we have, you know, YA1 it's just the PA over PT. So using Raoult's law gapon, no, we can use that. So the PA is the partial pressure, or we can use the vapor pressure, 165 over 760. That's 0.217. Okay, we have we have this na, we have Z, we have this, wala pa, we don't have that later. We have this na, we have this, Z is Z. So if you are wondering what Z to use, just get the average, no, average. So 18, and then that's the beginning, no, and then the final, diba, it was decreased by 9.5. So just add 18 and 9.5, you have 27.5, diba? Then get the average, because we have to get the average because the length is varying. So we have to get the average of that. Then we have 2.5 millimeters. Okay, plugging in all that we know. No, we have C today. We don't know C yet. So C is equal to P over RT, diba? P over RT. So we have 1 atm over 0.0821, and then times 290. Okay, you will have a 0.042 kmole per M3. So if you are wondering how I got that, just resolve it again, no. 821 ang units is pwede siya liter per mole, ano, liter atm per Kelvin mole, or pwede siya kilomole atm per Kelvin per cubic meter atm over Kelvin kmole na siya. So muna siya ang one. So you can plug this in, no? So plug everything we know. So you have 1.626. No, actually you know na all, and then just solve for dv, dv, shift solve lang dayon. dv you can find pila man, 1.91 times 10 to the negative 5 square meters per second. Okay, that's letter A. It's letter A. Yeah, just solve it on your own. Okay, so next number 31, a sphere. Kung sphere, if we are talking about sphere, you can find this in Jan Koplis, no? Dan ko please. This is this one of the example, no? So it's an example 6.2-4. If you have wala niyo siya nakita dito, it's your lucky day. Ako siya nakita. You can refer to that. Okay? So we have a sphere, diba? So we have a sphere. Sphere there. So you have diffusivity of 6.92 times 10 to the negative 6. Na siya. And then we have the diameter of the sphere is 4 millimeters. Then radius is 2 millimeters. Syempre. So you have 318 Kelvin temperature and 1 atm pressure. PVP is 0.5 gabi na did not reach 1 mmHg, no? And then we are to find the flux. Okay, so JA, or this is equal to NA over A over T. Yan. Okay, so let's outline, no, what equation we will use, no? This is it belongs to unicomponent nga diffusion because the naphthalene can't the air can't diffuse into naphthalene, but the naphthalene only will diffuse into the air, diba? Yani. So muna, naphthalene is mothballs. Kung if you haven't seen that, naphthalene is mothballs, and it's really humot, no? RT. So dV. So instead of Z, no, we use R, or the radius. And then have this formula, PA1 over PA2 over PBM. PBM is the mean pressure of the other, or of the air, guys. Air man. A is naphthalene, B is the air. Okay, so it's what values will we use, no? So R is equal to 8314. This is in cubic meters per Pascal over kmole K. Yan. So PA1, this is easy because you just have to divide this, no, by the atmospheric pressure, 760 or 1 atm, and transform that to pascals. You have 74 pascals. And then PA2 is, syempre, don't have let's assume na you have no naphthalene in the beginning of the air, so it's just 0. Okay, the PB1 is the total pressure minus the PA1. Okay, you have 101,325. That's the pressure of the air around it minus the 74, you know. So you have 101,251 pascals. Okay, PB2 is just equal to the atmospheric pressure, which is, that's the air, no? Does not change on any state. Okay, PB2 is that's why it still remained the same, because air cannot diffuse into the naphthalene bonds. Okay, only naphthalene can diffuse into the air, so that's why. Okay, so PBM is actually the average, no? Average of PB2 and PB1. I'll just get their average, no, arithmetic mean. You can get the 101 at 288 pascals. Okay, so far check na ni DV, check na siya. So we are just finding the JA, no? So plug in all that you know, okay, plug all of it there, you can find the answer is 9.69 times 10 to the negative 8 kmole uh, per square meters per second. But what is required here is the gram moles, no? Gram moles per second. So gram moles per second. So just multiply it by 1000 and then you will get 9.1. 9.68 times 10 to the negative 5. Yeah. Okay. So next is we have to get so we are required in moles per second, so we have to multiply it by the area. Okay, so area, so this is 9.69 times 10 to the negative 5 gram mole per second. So let's multiply that by the area. Okay, gram moles per second naman so dayon we have 4 into 0.004 meters squared. So let's try that. If we can get another solution to the our problem. So okay, times 0.004 second. Okay, actually wala siya. So the answer, really answer this is letter B. But in the answer key bitaw, no, it's letter A, but I don't know why. Why is it letter A? But in the Janko please, the answer is letter B. Okay, so I don't know why. Kasi nga, nasa iyo lang siguro sila, no? Number 32 is actually a transformation from, you have to transform one from equimolal, from unicomponent to equimolal. So how do we do that? So I really don't have the table, for this, but you can just stick with me on this one na lang, number 32. So this is how you can transform that if you are just given the molar fractions. You can transform that by using this. So ky prime is the equimolal, kung may prime, equimolal, kung wala, it's unicomponent. That's at least the convention that I use, and also our teacher Miss Laramie Lundas uses. Okay, so you have ky, and then you have yb lm, or the logarithmic mean. So let's I'll show you how you can get that. Okay, so you have ky is equal to 3.25 times 10 to the negative 5 kmole per s per square meter, diba? And then you have ya1, that's 0.26, ya2 0.01, diba? So just get the yb1, that's the difference lang, no? So 0.74, just subtract it from 1, or subtract it to 1, no? And yb2 is 0.99. Okay, so yblm now is the logarithmic mean. So this is just a plug and play, it's really simple na. We have 3.25 times 10 to the negative 5. We have 0.99, 0.74, ln 0.99, 0.74. That's how you get the logarithmic mean of P. Then we'll have your ky prime as 2.792 times 10 to the negative 5. Okay, so just copy the one. Just copy the units. Okay, so now let's move on to number 33. So we are just required to transform the our answer from number 32 to pound mole per hour per square feet per ATM. Diba? So let's do that. Okay. So 2.792 mole per. Yan. So just use the kuan. Hindi siyang ATM per ATM is just the mole fraction siya, no? It's not really a kuan, because if you base makita mo, if you have maybe if you you will have a hard time finding how ATM it came there. It's just a mole fraction, no? Mole fraction na siya. It really doesn't it has a impact in your calculation, but in here in your conversion it does not. Okay, so I have kmole, 1,000 gmoles in kmole, and then 1 pound mole is equal to 454 gram mole, diba? And then you have 3,600 seconds in 1 hour, and then you have 0.3048 meters in 1 foot, diba? That's squared pagid, square pa yan siya nimo. So you will have now 0.025 will be mole per square feet per hour. Okay, so that's letter B. Okay, so number 34, we are happy na to siya, mahapit na human. 34, penetration theory. Where can you find this in your Paris? You can find this in your Paris. Just check equation 5-303. Okay, so this is what is written there. KL is equal to 2, and then you have DL pi p. Okay, so just take out the square root of pi. You will have 1.13. So DL over P. So we have to get the factor, no? If we triple the time, so 1 over 3 na siya time, diba? If you butang ng 3 diha, and then so ang factor is 1 over square root of 3. Put that in your calculator. May mo siyang 5773 or 30, diba? Yan. Number 35. So number 35 is just really straightforward, guys. You know now. Okay. So use this equation, Na over 80, and then you have C. Okay, this is what I've used earlier. dV Z ayun ln ya2 or 1 or ya1. Okay, so Na, you can use this. So katong what I have shown you earlier, diba? Get the volume first, and then get the moles, no, the moles. So what I've got here, so I'll just ano lang, no, uh, how I one 2.097, I think this is 8 kmole. Okay, this is my Na. Oh, this is my Na. Okay, so A is you can get that by this, diba? A siya. T is actually what you are searching for, diba? Ikaw ba si Mr. T? Mr. T. So why A? Because this is unicomponent, no? So 0. Why A1 is just 180 over 760. So that's 0.237. Yeah. So check na siya, DV, you have DV, no? Kini DV. Kini siya, check na. And then just transform that to proper. So don't forget to transform, no? To proper units. And then you have this also, which is 10 millimeters. So you have this C, no? That's P over RT. So you know this already. So P, you have pila man? 1 atm, yapon 1 atm. And then T is 298 because kani 25, diba? Degree Celsius. So shift solve to find T. T is equal to 31.6 hours. Okay, 31.6 hours. So of course, ang mugawas ana is hours na in seconds or depende sa gyud sa niyo siya pag convert, but 31.6 hours ang answer. Okay, so that ends this video, no? I really glossed over that last number because it's really simple, no? And still I am using the same book I am using for the past time, no? This is the reviewer for chemical engineering, no? So yeah, this book really helped me in my self review. If you have time to buy this, just buy this, and then yeah, I can buy this in the bookstore. Shopee or Lazada. Yeah, so that's it for my video for the two-part diffusion video. Please subscribe if you haven't yet. Click the notification bell so that you won't miss a single upload of my videos. Okay, so I really thank you all for supporting my content. Okay, so I was really shocked to get to 600 subscribers just a short time, from 590. So almost one day again. So I really thank God for that, and I really thank you, the supporters of this channel. Please share this to your friends. Share to this to people that need these types of video. Good. Okay, so that's it for my time with you. So yeah, bye.